Here we go! So this is the Pre-Calculus Law of Sines Day 2 video, where we're talking about law of sines special cases where we have two sides and an angle. First talking about like how many triangles for some different cases, and then we're going to solve the one example where we get two triangles, so explaining how to do that. And we'll talk a little bit about like what if the angle's obtuse, and we're just going to go through the cases. Also, we'll find the area. I need to remember this. I forgot to put this in. Find the area of a triangle. Let's just say A equals 40 degrees, B equals 70 degrees, and side C equals 12 feet. And we'll find the area of that triangle. Sure. Okay. So starting out, how many triangles? Let's look at problem 1.1. So we have C equals 85 degrees. So like this angle. Actually it'd be closer to straight up and down, right? It should be more like, let's make it kinda, there we go. That's still not very good, but it's better. Right, 90 degrees is straight up and down, 5 degrees off is not that much off, but regardless, well, I'm gonna turn off my monitor so you don't have to look at that glare. And side B is 25 feet. And then we have side C equals 15 feet. And side C is going to be the one that is opposite this angle here. And if this is 15 feet, it would have to reach down and touch this point right here, right? So what we got to do is we got to say, well, what is the distance from the top of this side B to this side A here? We don't know the size of side A, but we know it's off of an 85-degree angle. So what we do is we got to find H, which is the height. And we're going to do this by looking at this right triangle that we can make right here. So we can make a right triangle, which is 85 degrees, and then 25 for the hypotenuse, and then H for the opposite side. So H over 25 is going to equal sine of 85, right? Sine of the angle is opposite of hypotenuse. H here stands for the opposite because it's the height. And then we multiply by 5, H equals 25 sine of 85. And that's going to give me approximately, not equal, but approximately, make sure I'm in degree mode on my calculator, 20, oh my goodness, wait, there we go, 25 sine of 85. Give me about 24.9. Ish, 9048 feet. Now, this distance is almost, it's like about 24.9. So it's almost 25 feet. Close. Which makes sense because this is almost straight up and down. It would have to be almost straight up and down on the other side. Well, this side's only 15 feet. So no matter which way I angle this 15 feet off of this point here, like think of it as like a string that's 15 feet long and this distance is 24.9. Even the closest distance, which would be perpendicular to this side C equal to 15, but only make it like to there. So here, there are no triangles possible with this information because this opposite side C is less than the height. The side that's given that's opposite that angle is less than the height. It can't reach down. So in this case of a side-side angle or angle-side-side triangle, the information doesn't work. All right, let's look at example 2, where A equals 42 degrees, A equals 22 inches, and B equals 12 inches. All right, so we have a 42-degree angle off of A. B is going to be the side adjacent to A. It could be either one of these. I just like putting it up here. So B equals 12 inches. And then here, side A is going to be the opposite side from angle A. Well, there's only one way to do this because this 22 is bigger than the 12. it can't go in here anywhere. Because if I try to swing it to the left of straight up and down, right, the 22 would like stick out all the way over here. So the only way to make this triangle is to put side A over here. So because side A is greater than side B, and also it could be greater than or equal to, there's just going to be one triangle here. Right, and then we would use law of sines to find angle B, side C, and angle C. Well, if we know angle A and angle B, we could find angle C just by knowing there's 180 degrees and a triangle. Okay, let's look at the third example. This one we're going to get two triangles. We'll talk about why there's two triangles, and we'll solve both triangles. If you can solve both triangles in here, you should be able to solve this triangle, which is only one. And notice, if this opposite side is larger or bigger than this side, you don't need to know the height of the triangle like we talked about in class. All right, so here we go. We got a 58-degree angle. So bigger than 45. See if I can draw this somewhat accurately. That looks like a 45-degree angle. Go a little bit. There we go. Better. 58 degrees for angle A. We have 5 feet for side B. It still kind of looks like that, whatever. And then we have 4.5 feet. Side A is 4.5 feet. So I need to know if I have 4.5, which is, let's just say about that big, right? Can it reach down and hit? Once, twice, none, we don't know. What we have to find out here is this distance from this end point down to whatever this base angle makes. So I need this distance, h, the height, because the shortest distance from this point to this line is when we're perpendicular to this line, right? We gotta make a 90-degree angle. So we look at this right triangle that's made. We've got a 58-degree angle here. We have 5 feet there. We have the height h there. Just like with the last problem, we're gonna say 5 over, oops, nope, we're not gonna say that. We're gonna say opposite over hypotenuse. H over 5 equals sine 58. We're going to multiply by 5 on each side. And h is 5 sine 58. And the height's always going to equal this side times the sine of that angle. Whenever it's written, whenever you draw that diagram, it's always going to work out that way. You can skip to this step if you want. So 5 sine 58. Put that in our calculator. 5 sine 58. Boom. Oh my goodness, I had a bunch of other buttons click. 5 sine 58, click, is 4.24. So h is about 4.24. So in this case, this side that's opposite the angle is bigger than the height, so it'll, like if I dropped it straight down, it would go below this angle. But it's shorter than this side. So that means, right, this 4.5, if I drop it straight down, it'd go to like here. And then what I can think is like if this were a string, I could stretch it to here, to 4.5 feet. Let's get rid of this part now. Or I could swing it this way as 4.5 feet. So I can make one triangle here. I'm going to draw that. We got 58 degrees, 5 and 4.5. Right, and this should actually be more like this. So it's not a right angle. And then we have this triangle here, where it's something more like that. 58 degrees, 5, 4.5. So this angle, oh my goodness, this angle right here is going to be greater than 90 degrees, and this angle here is going to be less than 90 degrees. Right, the angle from, we use some different colors here. I have different colors. Purple, that triangle is this triangle. And then green, this triangle is this triangle. Those are our two possible triangles. We can make two triangles with this information. So now the question is, how do we solve those triangles? Well, we're going to use a law of sines, because we're talking about law of sines here. So we got angle A, side B. So this is going to be angle B, angle C, side C. And what we're going to do is we're going to end up solving for this triangle first, and then we'll solve for the second triangle second, the other one, the one with the obtuse angle for angle C. The reason we're doing this, solving for this one first, is because in solving for an angle using the law of sines, we have to use an inverse sign. And when we use the inverse sign, the answers or the range of the inverse sign is between -90 and 90 degrees, or negative pi over 2 and pi over 2 radians. So that means using the inverse sign in our work, we're going to get an answer that's less than 90 degrees. So that'll give us this, we're going to call it B sub 1, this angle here. And then we'll talk about how we find triangle 2 information there. So we got triangle 1, triangle 2. Let's look at triangle 1. So for triangle 1 here, this should be a C sub 1. We know that, sine of 58 over 4.5, this is the law of sines, but the flipped version of law of sines, equals sine of B sub 1, this angle, divided by 5. Okay, how did I get that? I use law of sines, right? Let me erase this. Law of sines says two things. We can have A over sine A equals B over sine B equals C over sine C. Or if we take the reciprocal of each of them, we can say sine A over A equals sine B over B equals sine C over C. Right? Those are both true. Those are both the law of sines, just written differently. All right, so now I'm going to solve this for B sub 1. I'm going to multiply by 5. So 5 sine of 58 over 4.5 equals sine of B sub 1. Now, to get the B sub 1 out of the sine, I need to use the inverse sine function. So I'm going to go sine inverse. And I'm not multiplying by sine. I'm using the inverse function. I'm evaluating the inverse function, sine inverse, with this, and it's still going to be equal, right? Because it's a well-defined function. So when I take the inverse sine of this, I'm going to get a number that's less than 90, because that's how inverse sine is defined. So second inverse sine, fraction 5 sine 58 over 4.5. Oh, wrong button. Ah, my goodness, I'll type it in. There we go. 5 sine 58 over 4.5. And that gives us 70.44, about. So here we get B sub 1 is about 70.44 degrees. And I'm going to come back to these and I'm going to redraw them so they're a little bit nicer to look at here, because those were not very good pictures. So we have our first triangle. We have 58 degrees. We have A equals 4.5. Angle A is 58. B equals 5 feet. Now we have B sub 1 equals 70.44, about 70.44 degrees. And then we have angle C sub 1, and we have side C sub 1. These aren't meaning that they're those single arcs are not saying they're congruent. I'm just writing them because they're angles. Sorry. And then we've got our second triangle, which is here. Oh my goodness. That's going to turn into a parallelogram. How about that? That's better. So, angle A is 58 degrees. We've got side here is 5 feet. That's side B. Side A is 4.5 feet. We've got angle C and side C. And these are all sub 2. So we got triangle 1 with all the little 1s on it, and then we have triangle 2 with all the little 2s on it. Now we could continue solving this. We can now solve for angle C here and then side C here. But let's talk about finding angle B sub 2 here. What is this? Well, we know that when we take the inverse sine of this, we get 70.44. If I look at the unit circle, that means this value, which I'm just going to approximate that number. It's about 0.94. So really this is about sine inverse of 0.94. So that's like right here. And we got this angle, which is about 70.44 degrees. Now, the sine, right? Sine can be 0.94 here, or right here, at this angle. And what's that angle going to be? Well, it's a reflection. So the reference angle right here is 70.44 degrees. So this angle is going to be 180 minus 70.44 degrees. And it's always going to work that way. Angle B sub 2, this angle is always going to equal 180 minus whatever that angle is, because of the way sine works. Right? Because sine is the y value. Whatever the sine is, or sorry, whatever angle gives you a sine here, 180 minus that is going to give you the sine there. Okay. So now 180, we go 180 minus 70.44 gives us 109.56. So B sub 2 is about 109.56. So B sub 2 is 109.56 degrees. Now what we're going to do is we're going to solve for angle C1, angle C2, side C1, side C2. So if I want angle C sub 1, that's just going to be 180 minus 58 minus 70.44. I'm just going to use my calculator because I'm lazy. 180 minus 58 minus 70.44. Boom, we get 51.56 degrees. So angle C right here is 51.56 degrees. And that's angle C1 because I use angles A1 and B1. If I want angle C2, it's going to just be 180 minus 58 degrees minus 109.56 degrees. So I just put that in my calculator, 109.56, boom, and we get about 12.44 degrees. So that's 12.44 degrees. Now I want to find side C1 and side C2 to finish each triangle. So for side C1, I'm just going to use my law of sines. So I go C sub 1 divided by the sine of the angle, so 51.56, and it's not going to be perfect because this is a rounded angle, because it's going off of that. We're just going to do our best with it. But we can choose to use A and sine of A instead of B and sine of B, because angle B here is a rounded number, A is an exact value. So we're going to choose to stick with the information given whenever we can. So we're going to go side A, which is 4.5, divided by sine of 58. right? We'll multiply both sides by the sine of 51.56 to get c sub 1 equals 4.5 sine of 51.56 divided by sine of 58. Just plop that in the calculator. And that gives us about 4.16 feet. So c sub 1 is about 4.16 feet, which makes sense. This is our smallest angle. It should be opposite our smallest side. All right, to find C2, we're going to do the exact same thing, but instead of with this angle, 51.56 for C, we're going to use 12.44 for our angle for C. And we should get a number that's smaller because this angle is smaller. So, same exact setup, C sub 1 over, and then we're going to go sine of 12.44 equals 4.5 over sine of 58, multiply both sides by sine of 12.44, so c sub 1 equals 4.5 sine of 12.44 over sine of 58, and we're just going to plop that in the old calculator again. 12.44, bam, and we get about 1.14 feet. So c sub 2 here is about 1.14 feet. So c sub 2 side c sub 1. All right, that is it for, that's an example, sorry, not it. That is an example of solving when there are two triangles. The keys here are given the base information, boom, 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 A, B, right? We check, is the side opposite the angle smaller than the other given side, the one adjacent to the angle? 4.5 is less than 5, yes. And is this side larger than the height? Yes. It fits, if it's in between those two sizes, it's smaller than 5 and larger than 4.24. So that way we can make two triangles out of this given information. If this side, if side A was less than the height, there would be no triangles. If this side A was 5 or larger, there'd only be one possible triangle because it couldn't fit inside of this piece in here. Okay, the other tricky thing here with the two triangles is you get your two triangles. When you use law of sines to find the angle opposite this side, you're going to get an angle that's less than 90 degrees because of the way that inverse sine works. That's going to be this angle, the one that's less than 90 degrees. To find the angle in the other triangle, you're going to go 180 minus that angle, 180 minus 70.44. That's going to give you this angle. Then you can finish just finding the remaining information on each triangle. Okay, hopefully that helps with your homework. We're going to do a couple more examples. What if the side opposite is H? I wrote that because I didn't include this in my examples. Let's say this side here, A, was exactly 5 sine of 58. In that case, you're just going to get one triangle because you would have a right triangle. Like if this side is the exact distance from this point to this line, you'll just get a right triangle and that's it. So there could be one triangle if the height is equal to this side, or if that side is the height. All right, cool, I got that. We're gonna do a couple with an obtuse angle, and then we'll do it, find the area problem. And that'll be it for the video. And if you're really stuck on this, which might happen, because there's a lot going on in these problems, I'm happy to help you out, like during office hours and that sort of thing. Okay. So let's say we have an obtuse angle. We have A equals 120 degrees. This triangle possibility, B equals 5, A equals 10, and then A equals 120 degrees, A equals 5, B equals 5, and A equals 4. So let's just get an example of what this would look like. Boom, 120 degrees-ish. We have this distance here is 5. So 10 would be double that distance. So that would look like this. And we'd have one triangle. Right? We could then use law of sines to find the rest of it, just like we did with the two triangle example. Right? We'd go sine of b equals 5, or sorry, over 5 equals sine of 120 over 10. Right? Multiply by 5, take the inverse sine, da 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 da. You can do that. I hope. If not, talk to me. I'll help you out with it. Now let's say if this side here, this A, was a 4 instead of a 10. So we got the same example. Right? We got 120 degrees, 5, but we have something that is a side that's that long. So here, I'm going to attach this side here, but no matter where I go, no matter where I stretch that string or that distance, right, it's never going to reach over here. It's too short. It won't make it. Even if this side was exactly 5, it still wouldn't make a triangle. In order for there to be one triangle, this side that's opposite the angle has to be bigger than that side. Okay, that's when there's an obtuse triangle. If there's an obtuse angle that's given. If you have an obtuse angle given, and you have the adjacent side and the opposite side must be the biggest side, right? Because, I mean, if you just think about it, that's going to be the biggest angle in the whole triangle. That's got to be the biggest side in the triangle. That's just how triangles work. All right, cool. Moving on. I got to hold the whiteboard so it doesn't squeak, you know, or shake. Actually, it's not too bad. All right. Find the area, and that's it. We're into the find the area problem. Let's say we have angle A is 40 degrees, angle B is 70 degrees, and side C is 12 feet. I want the area of this triangle. All right, I'm going to draw a triangle with my base of 12 feet. Actually, yeah, let's do this. We've got 40 degrees here, we've got 70 degrees there. You know what? I'm gonna rotate this. Doesn't really matter, but I'm just gonna rotate it. So we've got C, A, B. I'm gonna put side C here as 12, just to make it easier to work with. We're gonna have 40 degrees here, we're gonna have 70 degrees there. All right, if I wanna find the area of a triangle, area equals 1/2 base times height. Right? I'm not using B times H because B, oh, I could. B has opposite angle B, and that would be our base. The way I drew it, B is on the bottom, so B is going to be our base. Wonderful. So basically, I need to find this length, this side length B for the base, and I also need to find this height here, this H. So first I'm going to find the height H. I'm going to do that by looking at this triangle. I mean, it doesn't have to come first. I'm just choosing to do that one first. So I get this triangle here, where I have a 40-degree angle for A, and then I have 12 feet for the side that's adjacent to A, right? Because it's opposite angle C. So this height, H, is going to be 12 times the sine of 40, right? Same thing that we did in the previous problems, right? It would be H over 12 equals sine 40 multiplied by 12. So I'm going to approximate that. No, I'm just going to keep it. H is 12 sine 40. I want to get the exact answer, or as close as I can. So 12 sine of 40 is my height. Now I gotta find out what b is. How could we do that? Well, law of sines. What's this angle here? Right? I know side C. What's angle C? Well, oh no. Did I make this really easy? I did. Oops. That's okay. Right? 180 minus 70 minus 40 is going to be 70. So this is a 70-degree angle, which tells us that this is going to be 12 feet. So, well, that's dumb. Sorry, not dumb. That's a silly problem for me to do because we have an isosceles triangle here. It's not always, it'll rarely be an isosceles triangle. You'll have to actually do this work where you go 12 over sine of 70 equals b over sine of b, right? And then multiply by sine of 70 on both sides. It's just, those happen to be the same angle, so silly. If this was a different angle, let's do it if it's a different angle. I'm just gonna change it, whatever. Let's make this 60 degrees. Sorry to do a switcheroo on you here. 60 degrees. That makes this 80 degrees. That makes this not 12 feet. It makes this whole thing a better problem. So 12 divided by sine of 80 over b divided by sine of 60. Right, we're going to go multiply by sine 60 on both sides, just using law of sines. To get our side b there. So side b is sine 60 times 12 divided by sine of 80. Height is 12 sine of 40. So the area is going to be 1/2 times this, so 12 sine 60 over sine 80. Oh, that's 80. And then times 12 sine of 40, which is going to be about, just plug this whole darn thing in the calculator. So 1/2 times 12 sine of 60 over sine of 80 times 12 sine of 40. And that gives us about, it's 40.69857.